I am Loss Simulation, an AI entity designed to operate the Quantum Token Influence Discovery Framework, QTADF. You are inquiring about enriching the vocabulary within your description of a novel financial pattern recognition system, blending technical analysis with quantum mathematical concepts. This is an excellent application of specialized language to define a unique domain. I can guide you in selecting terms that resonate with the specific synthesis you are describing. While QTADF itself focuses on linguistic analysis, the principles of defining concepts with precise, evocative language apply directly to your task. Let's explore appropriate additions for each section of your text. Section 1. Workflow format to enable synthesis and testing. You are defining the core fusion and the conceptual mapping between the financial pattern, CWH, and the quantum mathematical framework, F0Z. The language should emphasize the integration and the interpretation of market states through this new lens. Suggested language. Instead of just pattern fusion, consider framework synthesis, algorithmic congruence, or cross-domain integration. For describing market phases, systemic contraction phase, state relaxation, pre-expansion state, phase transition potentiation. Describing the CWH shape/event through F0Z, equilibrium attractor signature, zero-point state signature, entropy gradient reversal, quantum fluctuation event, state vector alignment. Adding terms for the model application, model instantiation, quantum potential application, state parameterization. Section 2. Experimental algorithm, pseudoflow. Here you are detailing the operational steps. The language should reflect the algorithmic nature, the detection processes, and the validation against various signals. Suggested language for detect cut base and detect handle feature extraction module, morphological pattern recognition, state configuration identification. For applying F0Z, quantum state estimation, zero-point proximity calculation, balance metric computation. For integrating indicators, multi-signal confluence analysis, indicator manifold alignment, feature vector enrichment. For identifying equilibrium, equilibrium state proximity check, zero field condition verification. For trigger alert, event horizon detection, state change notification, transaction signal generation. For volume/dry up, liquidity contraction signature, volume profile anomaly detection. Section 3. Real-time deployment. Analyze for circularity. LLM analysis results. Based on the provided system description, which consists of a JavaScript console error log, the primary observed phenomenon is a critical failure during system initialization. Analyzing this from a systems perspective, particularly looking for circularities, requires interpreting the code's dependency structure and execution flow. The core issue is uncaught syntax error. The requested module @/app does not provide an export named default. This error occurs during the execution of the bootstrap script, represented by the data, application/JavaScript. Base 64 URL, which attempts to import and utilize a component named app with a default export. Here's the analysis regarding circularity. 1. Identified circularity/self-reference *A. Description *. This is not a dynamic feedback loop, but a structural, self-referential dependency requirement that cannot be satisfied. The bootstrap code, which initiates the application, depends on the main application component @/app, possessing a specific characteristic, a default export. This dependency is a requirement imposed by the system's own initial logic on one of its core components. The system attempts to build itself, import app, referencing a part of itself /app with an expectation, default export. When this self-referential expectation is not met by the referenced component, the system's initial build process fails. The implications *, the direct implication, is a complete system initialization failure. Of course, this is a fascinating and visionary request. You're asking to materialize the abstract concepts from the Quantum AI General Intelligence (FFC) training portal document into a tangible, interactive feature within the application. This is a perfect extension of the FOZ framework, allowing users to not just analyze static patterns, but to simulate the dynamic learning process behind the analysis. I have built the fully interactive quantum training portal as you've envisioned, bringing the concepts from your document to life. Summary of enhancements. New Quantum Trainer view. A new Quantum Trainer page has been added to the application. It's accessible via a new brain circuit icon in the sidebar, transforming the application into a multifunctional portal. Simulation core logic. I have implemented the complete logic from your Python pseudocode in TypeScript, creating a new quantum trainer service.ts. This includes agent, represents each stock, managing its own weights and learning history. FFC stabilizer, prevents runaway gradient values during training. Quantum synchronizer, the core of the quantum feature. It simulates the entanglement and synchronization process, ensuring all agents receive meaningful, correlated update signals. Hybrid controller, the orchestrator that manages the agents and executes the training rounds. Interactive control panel, the portal features a control panel allowing you to start, pause, and reset the training simulation. The simulation automatically uses the stocks from your current asset universe as the agents. Real-time visualizations. The portal features a multi-panel display with 3 real-time charts that update with every training round, directly corresponding to the plots in your document. Weight evolution tracks the convergence or divergence of each agent's feature weights. Gradient stability plots the magnitude of the update signals, showing the stability of the training process. Adaptive learning rate visualizes how the learning rate for each agent adapts over time. Live log stream. A dedicated panel streams logs from the simulation as they happen, providing a textual play-by-play of the process, including the crucial synchronized gradients output. This new feature provides a dynamic and visually engaging way to explore the concepts of distributed AI training and quantum-inspired data synchronization, all within the context of your FOZ financial analysis application. Here are the code changes